Okay, we're going to review Pythagorean theorem from junior high. We've talked a little bit about it already this semester, but we're just reviewing it a little bit more here. So, just going to set up my screen a little bit better. Okay, so there's a right-angled triangle. We call these the legs of the triangle, the two sides that form the 90 degree. Okay. And the hypotenuse is opposite the biggest angle, the 90 degrees. It's the longest side. So when you think about the Pythagorean theorem, sometimes people think about A's, B's, and C's, but really think about the hypotenuse squared. The biggest side squared is equal to the squares of each of the legs added together. So the sum of the squares of the legs. So let's practice. You've been doing this for a few years. So calculate the length and round to the nearest tenth. So if you want to call it h for hypotenuse, then that's going to be equal to 3 squared plus 4 squared. Okay, and then that's going to be 9 plus 16, which is 25. So h is the square root of 25. Hopefully you remember that that's 5. Okay. And that's going to be centimeters. So this is 5 centimeters. I'm just going to make my pen a little bit thinner. Okay, so the next one, same thing. Hypotenuse squared is 5.4 squared plus 12.2 squared. So we'll use our calculator for this one. So we'll clear 5.4 squared plus 12.2 squared is 178. So h equals the root of 178. So now we go square root of that answer. If you have a graphing calculator, or some of you might just press the square root button. And 13 point, says round to the nearest tenth, so 13.3 centimeters. And then this one, same thing. So h squared equals 8 squared plus 10 squared. That's 64 plus 100, so 164. So h is the root of that. .8 centimeters. Okay, so then what if we need to calculate the length of an unknown leg of the triangle? Okay, so that means we're looking for, in our Pythagorean theorem, we're looking for either A or B. It doesn't matter which one. So that means we want to subtract when we bring the other leg over. So here I'm going to call this A. So A squared equals the hypotenuse squared minus the other leg squared. It's always going to be the hypotenuse squared first. Okay. And you can do that in your calculator if you want. So 57. So A will be the root of 57, and to the nearest tenth is 7.5. Remember that it's a leg, so it cannot be bigger than 11. So if you added, you would get something bigger than 11, and that wouldn't make sense. Okay, same with the next one. So here a squared equals the hypotenuse squared minus the other leg squared. Okay, so I'm just going to kind of put my calculator off. You may not see the whole thing, but okay, you can see it on my screen. Enter. And so that's 145.73. So A is the root of that. And and then the square root is 12.1. And again, got to be smaller than the hypotenuse. All right. Now, this one says express as an exact value. We've already gone through simplifying radicals, so that's what we're going to have to do. So this is h, so h squared equals 4 squared plus 6 squared. You can do that on your calculator if you want, but you're going to get 52. Okay, so then h is the square root of 52. And we have to simplify that. So remember, split that up into a product of a perfect square and another number. So 4 goes into that, and you're left with 113. Okay, so that means this is equal to 2 root 13. Right? If we take the square root, that's your perfect square. It gets to go out on the weekend. It's worth 2, and the 13 has to stay home. Okay. Now, the next one, we're looking for a leg, so let's call it a. So a squared equals 6 squared minus 4 squared. So 36 minus 16 is 20. So a is the root of 20. Well, 20 is 4 times 5. So the root of 4 is 2, and 5 has to stay home. And these put in the units, that was meters, this was centimeters. Okay. So some practice here. Determine how far up a wall a 7-meter ladder will reach if the base of the ladder is 2 meters from the wall. So you can do a quick little sketch here. So here's your building or your wall. Let me just make it a little bit bigger like that. Here's the ground. Here's a ladder. Okay. And so it says determine how far up a wall a 7-meter ladder, so that means this is 7, will reach. So we want to know what this is. Assume the wall is perpendicular and the ladder is 2 meters from it. Okay, so we're looking for, in this case, the height, which let's call it x. So x squared equals the hypotenuse squared minus the other leg squared. It says to the nearest tenth. So x is the root of 45. So if you've done the other calculations in there, that's fine, but you can do them in your head and then round this to the nearest tenth, which is 6.7 meters. Oh, just moved. Okay. Next one, determine mathematically whether a 25 centimeter microphone will lie flat on the bottom of a box measuring 14 by 20. So if I draw a rectangle like this, 14 by 20. So the longest would be 20, this would be 14, and it's a 25 centimeter microphone. So obviously I can't put the microphone long ways. So how will it fit in? Basically, we want the most we could fit in is if it was in the diagonal, right? That's the longest side because these are at 90 degrees. And so what is that? If it's at least 25, then we're good, providing the microphone isn't too fat around, like if it could fit in corner to corner. So let's call that C. Notice how in this triangle here I have 14. If this is 20, then this is 20. Okay? If this is 14, then this is 14. So our C squared will equal 14 squared plus 20 squared. Okay, if you need your calculator, then do that. 14 squared plus 20 squared is 596. So C is the root of 596. And let's see. I think we'll be good because the root of 625 is 25. So 24.4. So providing it's not, oh no, sorry, that's not good. That's too small, right? We have a 25 centimeter microphone, so this is less than 25. Therefore, no, it will not fit. Okay. And then determine whether each triangle is a right triangle. So we're trying to decide if that really should be a 90 degree there. So if it works, it means that these sides have to satisfy the Pythagorean theorem. So remember, our c squared equals a squared plus b squared. I'm going to split this up, okay, kind of, I call it a T-chart, okay. And so I always have to choose the longest side for my c, so that'll be 13 squared. Figure out what that is. And then the leg, so 10 squared plus 8 squared is 100 plus 64 equals 164. They are not equal, so no, it won't be a right triangle. Okay, so we can't put the 90 degree there. This one, same deal. Okay, so our c squared is 20 squared, which is 400. Our a squared plus b squared is 12 squared plus 16 squared. Get out your calculator. 12 squared plus 16 squared is 400. Right away, we're good. Left side equals right side. So yes, that should be a 90 degree symbol. Okay, and then that kind of leads into the next one. Determine whether each set of 3 numbers is a Pythagorean triple. If it's what's a Pythagorean triple means it satisfies the Pythagorean theorem, and you always have to look for the longest side. Okay, so pretending it's a side. These are just numbers, but you'd put your c squared would be 35 squared, and then your a squared plus b squared would be 21 squared plus 28 squared. So you can get out your calculator, 35 squared, then 21 squared plus 28 squared. They are the same. So left side equals the right side. So yes, this is a Pythagorean triple. Then let's check the next one. Biggest number is 40. Okay, so that's 400. And then what's 15 squared plus 36 squared? Oh, that's not very much at all, is it, comparatively? So 15 squared plus 36 squared is 1521. Oh, you know what? And 40 squared is not 400. That's why there's an issue there. 40 squared is 1600. And so these are not equal. They're close. So this is not a Pythagorean triple. Okay? And then questions from your workbook. All right, so you're done.